Hi everybody, these are Unit 11, Notes number 5. We're still working on special parallelograms, but this time we're going to focus on the square. So the technical definition for a square is a parallelogram with 4 right angles and 4 congruent sides. So remember that means that it is equiangular, and that means it is also equilateral, which brings us to this next statement here, that the square is the regular quadrilateral. So if you remember from the very first section of notes in Unit 11, we talked about regular polygons. Regular polygons were both equiangular and equilateral. So the official regular quadrilateral's name was the square. So you might also know that this kind of sounds a little familiar because that's what we were just working with in our last section of notes. We had the rectangle, which had the 4 right angles, and then we had the rhombus, which had the 4 congruent sides. So I like to think about the square as like the little baby of the rectangle and the rhombus. The square will have everything that the rectangle has, and it will have everything that the rhombus has. So that's what I want you to think about as we take a look at our key ideas for the square. So these will look super familiar. First one, all angles are 90 degrees, that's the rectangle. But in addition, all sides are congruent, that's the rhombus. As far as the diagonals are concerned, diagonals are congruent, like the rectangle, but they're also going to be perpendicular, like the rhombus. Also kind of blending the rectangle and rhombus together, you'll see that the diagonals bisect each corner, but in addition, we know that it's going to bisect and create 2 45-degree angles. So if I just kind of draw one diagonal in here, you can actually see it for yourself. That diagonal is going to come into this corner and cut it in half. Well, if that corner is 90 divided by 2, well, that just gives us 45 degrees. So on the top is 45 and on the bottom is 45. And then last but not least, the diagonals will break the square into 4 congruent isosceles triangles. Again, the perfect kind of fusion, if you will, of the rectangle and the rhombus. We know that we've got these 45 degrees everywhere in the little corners, but yet we also know that all the diagonals will be the same. So what we end up seeing, is that each of these triangles is a 45, 45, 90, because again, we've got that perpendicular in the middle. So again, the square is this perfect fusion, this perfect blend of the rectangle and the rhombus. So anything you think about for the rectangle, it applies to the square. Anything you can think of for the rhombus, it'll apply to the square. So let's get started with some examples. All right, so these types of pictures are now becoming more familiar to you. So we have diagonals SU and AQ, so SU and AQ intersect at point R. Find the indicated lengths and measures of the square. All right, so let's start with the sides. So we've got AU, well that's this bottom side here. Again, remember that square is part rhombus. So what that tells us is that every single one of these sides is going to be the same. So since there's a 7.1 over here, I know that there's a 7.1 all the way around. So that's a little characteristic it got from the rhombus. Now when we take a look at our next one is AR. Well, the AR is in the inside, it's part of a diagonal here. But remember, the square is also part rectangle. So remember, with a rectangle, the diagonals are equal. And then based on that characteristic from being a parallelogram, we know that the diagonals also bisect each other. So if this is a 5, then I know all of these are 5. So I've got a 5 all the way around here, and therefore answering that second part right there, AR Well, that's going to be 5. Let's see, SU. Well, SU is just this larger diagonal. Not larger, they're the same size. But this diagonal here, so S to U is 5 plus 5, which gives us 10. AQ, well, that's just the other diagonal, 10. So again, further confirming that because it is part rectangle, I know that the diagonals will be the same. And then QU, well, that's just this side right here, the 7.1. And again, because it is a parallelogram, we know that opposite sides are congruent. So even if I hadn't told you this was a square, we still would have known that was 7.1 because it was opposite this 7.1. Now, as far as the angles are concerned, you may stop and kind of say, well, wait a minute, what am I going to do with angles? I don't have anything. But the cool thing about the square is there's only 2 possibilities. You're either going to have a 45 degree or you're going to have a 90 degree. So let's kind of spell that out for us. Let's take a look at A. We know that the square is part rhombus. The rhombus's diagonals intersect and form 90 degrees. So right off the bat, guys, you're going to have 90 in everything in the middle. So that A value is 90 degrees. But not only will it have 90s in the middle, because it's part rectangle, it's going to have 90s in those corners as well. And that's what B is asking for. So remember we talked about with that darkened kind of angle arc? That means I'm looking for that entire angle. So yeah, this is 90 in here, just like all of these total 90 in each corner. So our B is 90 degrees. Now if you take a look at C, and C is in this upper right corner here, okay, notice that he is only part of that 90. We're not saying C is 90. But now again, let's go back to what we talked about on the other page. We know that the diagonals will bisect each corner because that's what it got from being part rhombus. So if this is 90, divide by 2, here's where the 45s come in. I know that C will be 45, just like this side will be 45. So C is 45, and that same reasoning is working with D. On either side here, we're going to have 45 degrees. So that is not just a coincidence, guys. Anytime I ask you about angles that are happening within the square, the only options are 90 or 45. Hopefully, even if you have to take your computer screen and kind of spin it around, you'll notice which ones are the 90s because they form those L's, and which ones are the 45s because they're definitely going to be less than the L. So moving on, that kind of helps us out with number 2 down here. Write and solve an equation to find the value of x in each square. If needed, round to nearest hundredth. Now, we haven't had to do that before because you know me, I like pretty answers. However, unfortunately, as nicely as that kind of went up top, when we actually are kind of trying to look for some of these sides or whatever, if they're not given to you, there are going to be decimals, okay? But that's all right. That's why you should definitely have a calculator, whether it be handheld or your cell phone, okay? All right, so start with number 2. Now notice where this angle, where this arrow is pointing. He's only pointing to that little mark there. Now again, because it's a square, I know the entire angle is 90, but the diagonal will have broken it up into 2 congruent angles. So that's going to be a 45 degree on each side. So therefore, since this 8x minus 3 is only pointing to half of the 90, I'm just going to set it equal to the 45. We'll add 3 over to the other side. That'll give us 8x equals 48. Divide by 8 on both sides, and that will give us 6. Easy peasy, lemon squeezy. Okay, I know I just said that, but now here's where it starts getting crazy. Now again, you know it's a square, and we know that all the sides will be the same in a square, so technically, yeah, I got an X all over the place, but how am I going to really find out what it means then, or what value is? So going through our characteristics again, remember that the square is part rhombus. So therefore, in the middle here, I know that they're perpendicular. I have 90s everywhere inside here. So rather than actually looking at this square as one big shape, I'm actually just going to look at a fourth of it. I'm going to look at just this little triangle here, which has the X and the 9 as its two sides. And furthermore, if you notice this right angle here, again, this goes back to some other things we learned, but across from the 90 degree is your hypotenuse. So I'm just going to go ahead and redraw this triangle off to the side here. I'm going to redraw it so it looks a little bit more like a right angle to me. So here's my 90, my hypotenuse is my X, and my side here is the 9. So what I really have going on here, guys, is just a right triangle where I have two sides and I'm looking for one. That is Pythagorean theorem. Now the question is, though, is where's that second side here? I know I'm going to be looking for this X, but what do I have down here? Well, guys, also remembering that this square is part rectangle, remember, if there is a 9 here, then there's going to be a 9 here. So that would be that missing side there. So what we really have going on here, guys, is a right triangle with 9 and 9 as the legs, and the X is the hypotenuse. So if I want to solve that, I'm going to plug it into the Pythagorean theorem. I'll write it down here real quick generically. Remember, that's a squared plus b squared equals c squared. A and b are both the legs, meaning the two sides that make up the 90 degree. So that's going to be 9 squared plus 9 squared equals x squared. 9 squared is 81 plus another 81 equals x squared. When I add those together, I get 162 equals x squared. And this is why, if I can grab it, this is why we said about making sure that we had our calculator, okay? Because unfortunately, I don't care how I try to find numbers. I can be up all night trying to find different numbers to work, guys. This will never be a perfect square, unfortunately. The only way for that to happen is if these were super ugly, and I'm not ready to put radicals and weird square roots in for you guys, okay? So it's easier just work with these nice pretty numbers up until the end, and then just know that at the very end, it's just gonna look a little ugly. I just went it around to 2 decimal places. So remember that to get rid of this x squared, we're gonna square root. So if in my calculator, I go ahead and do the square root of 162, I'm getting 12.72, and then the third digit is a 7. 5 or above, give it a shove. So that's going to round up to 12.73. So 12.73, that will be my value for x, which is this side right here. All right, one of the last problems we do for the square. Okay, now what I did is I kind of switched the idea of where the unknown was. So this time what you're going to see is that now I made the x in the middle as part of the diagonal, and I made the value that was given one of the outsides. But we're going to do the exact same thing. Let's focus on the part of the square that makes that right triangle. So that would give me this top part here, because this is where I've got my 2 values. And let's do this before I even draw the triangle. I didn't do this in the last one, but I should have. Remember that we don't have anything on that third side. But again, because the square is part rectangle, I know that all of these little pieces are the same. So if an X is on one part, then I know that there's an X on the other part. I mean, technically all of these are X's, but again, we're mainly focusing on just that triangle right up top here. Again, because it's part rhombus, I know that this is going to be a 90-degree angle. This will be your right angle. And across from there is your hypotenuse. So this time when we draw our triangle, we're actually going to have the hypotenuse be our number and the x's be our sides, our legs. So I'm just going to redraw this down here so it looks a little bit easier to see. Okay, so here's my right triangle with my 90-degree right here. Across from the 90 is my hypotenuse, which is the 22, and then my two side lengths are both x. So again, the legs, the sides that make the 90-degree, they go first. They go on the left side here. So we've got x squared plus x squared equals 22 squared. That's going to combine to give us 2x squared. I know it seems a little weird, okay, but if you remember, x squared and x squared is no more than just saying x plus x. When you're adding these things with exponents, do not add the exponents, okay? That's something with like multiplying and everything like that, product property rules. You'll do that again early on in Algebra 2. Right now, just remember that you've got 1x squared here, and then you got another one, so that just means you got 2 of these crazy things that we call x squares. 22 squared, I think it's 484, only because I did a problem in algebra. Yep, 484. Now before I can go ahead and square root though, I've got to get rid of this coefficient first. So we're going to divide both sides by 2. We've done problems similar to this. This will be x squared equals 242. And now we will square root to get x alone. Okay, and I get x equals 15.56. It was another kind of circumstance where behind this guy was a 6, so I bumped this guy up. He was originally a 5. So again, guys, when you have a problem like this, yes, it's going to be ugly, okay? But again, it'll just be ugly at the very end, and I'll ask you to round to 2 decimal places, okay? So now that we've got the square, now it's ready, we're ready to put this all together, okay? So putting it all together with all these parallelograms, okay? So we started out this unit talking about polygons, which were just figures that had straight sides, were closed. Then we focused on the quadrilateral, in particular the parallelogram, which had 2 sides, the opposite sides being parallel. And then from there, we branched out into some other special shapes. Okay, so just to review, guys, we had that parallelogram, and then we added some special things to them to make them special parallelograms. So I'm actually just going to write that on the side, just so we remember that even though we do call the rectangle a rectangle, it is technically a parallelogram. It's just a special one. And then same thing for rhombus. We call it a rhombus. Some people call it diamond. But all it is a special parallelogram. It's a parallelogram that has some extra special features. And honestly, guys, that's really what now has happened with the square. We've taken that parallelogram and we've added some special stuff to it. So the square is also a special parallelogram. So a parallelogram can show up in a lot of different forms. It could just be kind of like your standard parallelogram that looks kind of like this, or we could straighten it up to make it a rectangle, or we could kind of condense it in so all the sides are the same, or we could do both of that and get this square. So all of these are technically parallelograms. Now the square though is even more special because we've put both the rectangle and rhombus together to form it. So we also would call the square a special rectangle. And then we would also call it a special rhombus. So this is where sometimes people get confused, because if I just say, you know, hey, draw me a square, technically, guys, if you drew this, oh, pause for a second. I lost my train of thought. If I said reverse, been too long in the video, I'm not gonna stop and rewind now. I don't know how to trim. I ain't fancy, I ain't tech. Okay, reverse. So if I said, hey guys, draw a rectangle for me, and you drew a square, you would not be wrong because a square is a special rectangle, okay? Just like if I said, hey, draw me a rhombus. If you drew a square, I would technically have to take that because a square is a special rhombus, okay? So, hopefully I didn't confuse you too much. Let's move on to these, okay? These can sometimes get a little tricky, but I like them a lot. All right, so basically what we have here, guys, is sometimes, always, never. And it's all going to be based on what we just talked about up here. All right, a square is sometimes, always, or never a parallelogram. Well, guys, look at the square. I just told you he's a parallelogram. He's just special. So that is always. He's always a parallelogram. He's just a special version of it. A parallelogram is sometimes, always, never a rectangle. Well, taking a look at the parallelogram, guys, we just said again, you could have a parallelogram that looks like this, or you could make it a little bit more special and have any one of these. So it's not that it's always going to go to be a rectangle, it's just sometimes. Because a parallelogram could also be rhombus or square. So the idea with the sometimes is if you can come up with another answer to satisfy this, then it's sometimes. Number 3, a rectangle is sometimes, always, never a rhombus. Notice, guys, nowhere on these sides did I say special rhombus, special rectangle. No, they're never called each other's names, okay? This is your never one, and it's pretty much the only never one you'll have, okay? Only never. All right, a rhombus is sometimes, always, never a square. So again, going back, let's say I told you to draw a rhombus. Now I did tell you if you drew a square, I couldn't mark it wrong. But at the same time, what if you just drew a slanted little square looking thing? Well, then you'd be correct there as well. So this is a sometimes. A rhombus could just be a slanted square looking thing, or it could be an actual square. And over here, a square is sometimes, always, never a rectangle. Going back to number 5, this is really saying the same thing. Take a look at all the special names we gave for a square. One of its special names is a special rectangle. So a square is always considered a rectangle. It's just a special version of it, okay? So I know this can sometimes be a little confusing, okay? So this is why I always say take down the notes. I'm not really gonna stray too far with these ideas, okay? But basically the rule of thumb, guys, is look for the special names, okay? And that'll kind of be your key to help you out. And then last but not least, here I am. Let's just put all together who's got what characteristics. And then guys, I promise you, these are the last notes for this unit. I have 2 more little sections for you guys, and then we're done with the year. Yay. Okay, so this is just to make sure that we kind of put this all together and you understand who's who and what special characteristics they all have. So number 10, I'm asking you, basically guys, for this section, I just want you to circle one of the parallelograms, one of the quadrilaterals there, for which the statement is true. And there will be more than one answer, okay? So the first one was, it is equilateral. Well, remember what equilateral means. It means equal sides. So if you remember, we actually have 2 shapes where there's equal sides. We've got the rhombus, and then we took that rhombus and straightened it up, and we made the square. So that's what we mean by sometimes we'll have 2 answers. Number 11, equiangular. Well, that's equal angles. And we first saw equal angles when we went to the rectangle because we had all those 90-degree corners. Well, that is also that characteristic that was passed on to the square. Number 12, the opposite sides are parallel. Well, that was our starting whole definition of a parallelogram. It's why it was called parallelogram. So we know that it's parallelogram, but we just talked about this on the last slide, guys, that technically all of these are parallelograms. They're just special versions of it. So in this case, guys, every single one gets circled. Number 13, the angles can be obtuse. So now just to clarify for this one, what we're talking about is the actual corners here of the figure. So if you think about it, guys, we know that if we're talking about the rectangle or square, well, all of those corners are exactly 90 degrees. They can't be bigger than that. So if anything, guys, the only way to get those obtuse angles is to kind of have that push, have that rectangular square that's been pushed over so it elongates and stretches out that angle. So in order for this to happen, guys, I always like to just say it has to be slanted. And that's exactly the look you get with the parallelogram and the rhombus. And 3 more, the diagonals are congruent. Well, again, this is kind of the opposite of what we were just saying with 13. If we have a slant, the one diagonal pulls out, creating that larger angle, that obtuse angle. So basically, if you want the diagonals to be congruent, okay, it cannot be slanted. Again, not a real fancy term here. But basically the idea is we're looking for the rectangle and the square. It's got to be standing straight up. Number 15, the diagonals are perpendicular, okay? Well, that first started happening with the rhombus, and that characteristic was passed on to the square. So remember we said that with the rhombus, all the 90s were in the middle, just as you have it with the square. And lastly, the diagonals bisect each other. Okay, well again, that goes right back to the idea of the parallelogram. The parallelogram didn't have his diagonals being perpendicular. It didn't necessarily have his diagonals being congruent, but first and foremost, we learned that the diagonals bisected each other. And again, because these 3 are special parallelograms, they share that characteristic as well. So this concludes our our parallelogram sections, okay? I know it might have seemed like a lot, guys. Make sure you've got some notes or at least the videos kind of on the side as you're taking your quiz to help you out. As always, please make sure you come see me. Please make sure that you text me or message me or email me if you have any questions, all right? And I'll see you for the next little section of notes shortly. All right, bye-bye.